Welcome to Sleepy Science Facts. I'm so happy you came here. Perhaps you had a long day, or perhaps you prefer to fall asleep to profound reflections and cosmic mysteries rather than sheep counting. In any case, you are the one on this journey tonight. The only thing you can do is sleep. Allow your body to become lighter as though gravity itself has loosened, your breathing too slow, and your mind to relax. We're not just stargazing tonight. For that reason, we are traveling through the Milky Way, our home galaxy. For more than 13 billion years, a massive spiral of stars, dust, and dark matter has been slowly rotating in space. But there are secrets hidden beneath its beauty. Invisible forces, rogue stars, and ancient relics that contradict our preconceived notions. From massive collisions to stars older than the galaxy itself, we will gently travel from its spiral arms to its hidden core. You will learn about stellar nurseries, black holes, and the intriguing unresolved tale of a galaxy that is still expanding. As you go to sleep tonight, you might be surprised by some of the things you hear, or at the very least, curious. Before we get started, think about liking and subscribing to the channel. If these serene, inquisitive explorations help you relax or provide you with a peaceful way to end your day, it also makes it easier for others to navigate this place, one drowsy person at a time. Let's get started. There will be another collision between the Milky Way and other galaxies. Although our galaxy may seem like a secure place to call home, it was formed from the remains of other galaxies. Smaller galaxies have been drawn in and unraveled, and their stars scattered into tidal streams that encircle the disk by the Milky Way over billions of years. The Sagittarius dwarf is one such galaxy that is currently undergoing disintegration. Andromeda is slowly approaching from afar in the night sky. The two great spirals will collide cosmically in roughly 4.5 billion years. The galaxy's shapes will change forever, folding into a new form, vast and quiet, but stars will hardly ever collide. Galaxies themselves are not eternal. They change, collide, and start over. The Milky Way contains stars that are older than the galaxy. Not all of the Milky Way's stars were born here. Certain halo stars appear to have formed before the Milky Way was fully formed. These stars are ancient metal cores that wander in long, tilted orbits. These stars may have formed in smaller primordial galaxies that merged with our own billions of years ago. According to astronomers, nearly no heavy elements can be found in their chemical fingerprints, indicating that they were created soon after the Big Bang. Like elder spirits from a time before spirals and before order, they travel slowly and high above the galactic plane. We saw a younger, wilder universe in their light, one that was still figuring out who it was. Over 828,000 kilometers per hour is the speed at which our solar system circles the Milky Way's center. That's over 230 kilometers per second. Even so, a single orbit around the galaxy takes roughly 225 million years. We refer to this course as a galactic year. Since the formation of the solar system, we have only made roughly 20 orbits of the Milky Way in Earth time. We were in a completely different galaxy when the first dinosaurs appeared. Today's stars weren't always close by, and they won't be forever. Everything is moving, silently, slowly, indefinitely. The Earth rotates while we sleep. The solar system as a whole moves forward through a moving galaxy while the moon circles. The galaxy continues to expand. Despite its age, the Milky Way is not yet complete. It is still collecting material today. Its halo is fed by streams of dark matter, gas from the intergalactic medium, and stars from dwarf galaxies that have been captured. It develops like a gravitational structure that gets deeper over time, rather than like a living organism, through infilling clouds. Some of this growth occurs in silence. In other cases, it is accompanied by disruption, with satellite galaxies being ripped apart and their stars dispersed throughout the sky. The dinosaurs did not live in the same galaxy as you do now, and it might be even bigger than the one your distant descendants may know. The remnants of 1,000 smaller worlds were used to stitch it. The number of arms in the Milky Way is unknown. It seems like we ought to be aware of it. How many arms radiate outward from our own galaxy's core? However, it is difficult to see the entire structure from our location deep within the disk. Remote areas are obscured by dust clouds. Stars merge with each other. Astronomers thought there were 4 main spiral arrows for many years. There may be fewer, or the arms may split and twist in more complicated ways than anticipated. According to more recent observations, some disintegrate into pieces. Others turn around without warning. The Milky Way is a living, layered swirl of stars, formed by forces we still don't fully understand. Not a neat pinwheel at all. The core tosses rogue stars out. A small percentage of stars are hurled outward at incredible speeds, fast enough to completely escape the Milky Way, while the majority glide peacefully through the galaxy. Hypervelocity stars are what these are. The galaxy's supermassive black hole upsets some binary systems, leaving behind their remnants. One star disappears as it falls in at more than 1,000,000 kilometers per hour. The other is thrown into the darkness and slingshotted outward. Like glowing comets, with no way back, these rogue stars travel far from the galactic plane by themselves. They serve as a reminder that peaceful expulsions that send stars hurtling into intergalactic night can occur even in a galaxy that is Andromeda and the Milky Way are headed straight for each other. The Andromeda Galaxy, which is located more than 2 million light-years away, is a spiral that resembles our own and appears to the unaided eye as a faint blur high above the horizon. Nevertheless, it is steadily approaching us. Andromeda and the Milky Way will collide in roughly 4.5 billion years. It will not be as violent as you might think. Stars are too far apart to collide head-on. However, both galaxies will be distorted into long arcing arcs by their gravity. The tails of the tides will curl outward. Black holes can spiral in unison. The two galaxies will combine to form a single, larger system after billions of years. It will be a graceful, leisurely dance. Our home's future is written in the stars. Some stars have backward orbits. The majority of the Milky Way stars travel in the same general direction around the center. However, not everyone abides by the rules. Some stars orbit counter to the galaxy's main rotation, moving in retrograde, particularly in the outer halo. These stars were probably born in dwarf galaxies that were subsequently absorbed, and they came from somewhere else. A subtle indication of their foreign ancestry is their reversed motion. The galaxy seems to be moving with memories from the past. Stories of cosmic encounters and ancient mergers are preserved in the slow, patient rotation of stars against the stream rather than in light. Dozens of dwarf galaxies might have been consumed by the Milky Way. The Milky Way has not expanded in isolation over billions of years. It has eaten. Faint Loma's companions, or small galaxies, have drifted near, been drawn into its gravitational pull, and gradually disintegrated. Our Arlo disk, or stellar streams, now contains their stars. Astronomers have used stellar motion and composition analysis to identify a number of these mergers. The Gonzalez merger, one particularly significant event, added a large number of stars and might have changed the galaxy's early structure. The Milky Way is not a perfect spiral. It is a composite constructed from the remnants of numerous smaller worlds sewn together by silent collisions. The origin of stars can be inferred from their chemical composition. Each star is born with a distinct chemical fingerprint, a pattern of elements. Astronomers can determine a star's past by examining these signatures. Heavy elements like calcium and iron are abundant in some stars, indicating that they formed in areas with a lot of metal. Others were created during the early stages of the universe and are almost pure hydrogen and helium. Because of these distinctions, scientists are able to classify stars into families, discover long-forgotten mergers, and piece together the secret history of the Milky Way's formation. Intisensei chemistry turns into a sort of time machine that allows us to read the stars' pasts like a line of old poetry in light. Stellar streams from shattered galaxies abound in the sky. Thin ribbons of stars stretch in arcs and curves across the sky. They are hardly noticeable, but when precisely mapped, they are unmistakable. These are stellar streams, the remains of smaller galaxies that were torn apart after wandering too close to the Milky Way. Tidal forces smear their stars throughout space as they orbit, creating delicate, long trails that retrace their previous routes. Some form spectral halos that encircle the galaxy, others plunge into the center. The Milky Way was formed over billions of years by silent mergers and collisions. as evidenced by these streams. Like a tree, the galaxy bears the rings of its history in each strand of light. It is a distorted Milky Way. Our galaxy is not a perfect spiral that lies flat. Its disk creates a beautiful wave across the stars by bending upward on one side and downward on the other. Until radio telescopes mapped the hydrogen gas that extends far beyond the starlight, we were unable to see this subtle warp. Scientists speculated that either clumps of dark matter bending the structure from below or satellite galaxies gently pulling on the Milky Way as edges could be the source of the distortion. The warp shows that even galaxies are never completely still, like ripples in a massive spinning sheet. They respond to unseen forces by bending, flexing, and changing shape over time. The Milky Way may appear to be slowly dancing across space when viewed from a distance. Only around 0.00003% of the Milky Way is visible to the unaided eye. A few thousand stars may be visible under a clear, dark sky, far from cities and streetlights. That appears to be an ocean of light to the human eye. But it's really just a droplet. There are more than 100 billion stars in the Milky Way. Most are out of sight. Some are hidden by heavy, dusty curtains. Others are too far away or too dim for us to see. On moonless nights, the Milky Way appears as a pale streak across the sky, but this is only the deepest murmur of the whole. Almost all of the enormous river of starlight that surrounds us is invisible to us because it is too big to comprehend from within. The speed at which stars orbit the galaxy varies. Stars in the Milky Way move more freely than planets in a solar system, which follow tidy paths around their stars. Others drift slowly along the outskirts, while others race ahead in the inner regions. Spiral arms develop as a result of this speed differential. They resemble slow traffic jams of gas and stars traveling through space rather than being solid structures. The arms are illuminated in curls of blue and white as these density waves cause new stars to form. This swirl, which moves in and out of these patterns over time, includes our own sun. There is no clock in the galaxy. We are floating in a current. There is something we cannot see that keeps the galaxy together. The Milky Way shouldn't exist. According to logic, our measurements of stars, dust, and gas indicate that the galaxy's outer edges are spinning too quickly. They ought to be hurled into the air, dispersed like leaves during a and yet they are still there. Dark matter is the solution. This enigmatic material doesn't emit, reflect, or shine any light. However, it exerts gravity, and it is so abundant that it greatly exceeds all of the galaxy's visible matter. Although we don't know what dark matter is, we do know that the Milky Way would disintegrate in its absence. Everything is held in place by the unseen scaffolding. At its center is a massive black hole. Sagittarius, an asteroid-escaped, singular point of gravity, is a massive black hole located at the very center of the Milky Way. It has a mass greater than 4 million times that of the Sun. Its space, however, is smaller than Mercury's orbit. Although we can't see it directly, we have seen stars in the vicinity circle it at amazing speeds, creating invisible circles in the empty space. As they spiral into the event horizon, gas and dust can occasionally fall inward and flare with X-rays. Sagittarius, an asterisk, is currently sleeping. It might, however, have blazed like a quasar long ago, illuminating the galaxy from within. It pulls stars into a slow, unrelenting dance, acting as the silent conductor of the Milky Way's heart. There is a peanut-shaped bulge in the Milky Way. Astronomers made an unexpected discovery when they mapped the galaxy's center. The central bulge is shaped like a three-dimensional peanut rather than a smooth, round ball of stars. When viewed from the side, it resembles a twisted hourglass made of stars, swelling in the center and narrowing at the ends. The galaxy's central bar, a thick band of stars that rotates slowly and gradually buckles and puffs upward, is most likely what created this odd geometry. Gravity, billions of years of motion, and the cumulative beat of stellar orbits have all shaped these internal structures. Although our galaxy is spiral, its core is intricate, complex, and alive. Not flat or clean, the spiral arms are shaped by stellar The spiral arms of the Milky Way are composed of more than just stars. They are made from the stars' birthplaces. Throughout the galaxy, massive clouds of molecules, dust, and hydrogen float. Additionally, these clouds are compressed and illuminated by newborn suns as they move through the spiral arms, known as stellar nurseries. These areas are tumultuous, bright, and dynamic. The arms are painted with brilliant blues and silvers as the clouds are illuminated by ultraviolet light from new stars. These creative outbursts outline the spiral form, casting silent fire along the galaxy's arcs. Long ago, one of these cloudy cradles gave birth to all stars, including the Sun. There is a huge halo around the Milky Way. The entire galaxy is surrounded by a spherical halo that is much more diffuse than the fat spiral disk. It has massive amounts of dark matter, globular clusters, and old stars. This halo's almost invisible, but it could contain most of the mass of the Milky Way. Its stars orbit in long, slow arcs that hardly ever touch the disk, dispersed thinly over enormous distances. The shells and streams of stars that were ripped from smaller galaxies and left behind like cosmic fossils, as well as the remains of old galactic mergers, are also preserved in the halo. Though silent and dim, the galaxy's outer memory is still active and continues to influence the Milky Way's future. There are more than 150 globular clusters in it. Globular clusters are some of the galaxy's oldest objects. Hundreds of thousands of closely packed stars form compact spheres. In the halo, they circle the galactic center like moths around a far-off flame. Some of these clusters are over 12 billion years old, have stars that predate the Milky Way, and are exceptionally stable. Since their stars formed before the universe had time to produce many of the heavier elements, they are metal-poor. As time capsules, they contain hints about the galaxy's formation, its diet, and the conditions of the early universe. Glowing in the dark, these silent golden spheres float calmly above and below the galactic plane. The galaxy continues to expand. Despite its age, the Milky Way is not yet complete. It is still collecting material today. Its halo is fed by streams of dark matter, gas from the intergalactic medium, and stars from dwarf galaxies that have been captured. It develops like a gravitational structure that gets deeper over time, rather than like a living organism. Through infilling clouds, some of this growth occurs in silence. In other cases, it causes disruption, with satellite galaxies being ripped apart and their stars dispersed throughout the sky. The dinosaurs did not live in the same galaxy as you do now, and it might be even bigger than the one your distant descendants may know. The remnants of 1,000 smaller worlds were used to stitch it. The core tosses rogue stars out. A small percentage of stars are hurled outward at incredible speeds, fast enough to completely escape the Milky Way while the majority glide peacefully through the galaxy. Hypervelocity stars are what these are. The galaxy's supermassive black hole upsets some binary systems, leaving behind their remnants. One star disappears as it falls in at more than 1,000,000 kilometers per hour. The other is thrown into the darkness and slingshotted outward. Like glowing comets with no way back, these rogue stars move alone and far from the galactic plane. They serve as a reminder that peaceful expulsions that send stars hurtling into intergalactic night can occur even in a galaxy that is the rate of star formation is decreasing. The Milky Way used to be more active, exploding with new stars formed from thick, collapsing clouds. However, the pace has slowed in recent eras. Gas is still present, but it is mostly heated, dispersed thinly, or trapped in forms that don't collapse. The galaxy is settling, but it is not finished producing stars. Star formation peaked billions of years ago, according to astronomers, and has been declining ever since. This simply indicates that we are living in a more tranquil era. Not that the end is imminent. A middle-aged, mature spiral that is still producing stars, but is not in a rush. Before the Milky Way had a disk, some stars formed. Over time, the disk's the wide, flat spiral that we know as the Milky Way. However, some of our galaxy's stars are older than the disk itself. These old stars were created when the galaxy was still forming. A loose cloud of stars, gas, and dark matter slowly collapsing inward. They are primarily found in the halo or the thick disk. Astronomers can look back into the time before spirals in structure by analyzing their motion and composition. These stars are the galaxy's elders, silent witnesses to its formation and the gradual, protracted formation of what we now call home. Between 225 and 250 million Earth years make up a galactic year. Every few hundred million years, the Sun completes a full rotation around the center of the Milky Way. This enormous cycle of motion, which dwarfs all of our calendars, is known as a galactic year. Whole epochs unfold, continents drift, and species rise and fall in the time it takes for the Sun to complete one orbit around the galaxy. We are believed to be roughly halfway through one of these orbits. At the moment, dinosaurs had not yet appeared, and the supercontinent Pangaea had just started to fragment when the solar system was last in this section of its trajectory. The languid pulse of cosmic time is a galactic year. Less than 25 galactic orbits have been completed by the Sun. The Sun has only made about 20 orbits around the Milky Way in its 4.6 billion-year existence. That's less than you might think, given its amazing speed of almost 830,000 kilometers per hour. However, each orbit takes hundreds of millions of years due to the size of the galaxy and the length of the Sun's path. The stars are frequently perceived as being old and immobile. On a galactic scale, however, our solar system is still young, a new arrival in a city of more established, well-traveled suns. Though it is still early in its convoluted history, we are a part of the galaxy's motion. Newton's theories are not supported by the Milky Way's rotation. Just as outer planets orbit the Sun more slowly, stars farther from the galactic center should orbit more slowly, according to Newtonian physics. However, stars in the Milky Way's outer regions orbit nearly as quickly as those in the center. This goes against what is typically expected. Astronomers think that dark matter, unseen, unidentified type of mass that envelops the galaxy in a massive halo is the cause. The galaxy would not be able to sustain itself without dark matter. The math works with it. The reason the Milky Way rotates like a solid wheel is not because we fully comprehend it, but rather because of an invisible force. There are massive molecular clouds in the galaxy. Large, dark clouds of cold gas, the building block of stars, are dispersed throughout the Milky Way. These molecular clouds, composed mostly of hydrogen molecules and traces of dust, can span hundreds of light-years across. Gravity starts to collect material in their cold, dense interiors, creating clumps that eventually collapse into new planets and stars. Some of these clouds appear as black patches against the starry sky because they are so big and so cold that they completely block out visible light. Tucked away behind curtains of gas and shadow, they are the wombs of the galaxy, quiet, secret places where the future begins in silence. Supernovae are like storms in the galaxy. When massive stars reach the end of their lives, they explode in cataclysmic supernovas, occurrences so strong that they can momentarily eclipse entire galaxies. These explosions don't just end lives, they create them. Supernova shockwaves compress neighboring clouds and start new star formation waves as they travel through the interstellar medium. With heavy elements like iron and gold forged in the dying star's core, they enhance the surrounding area. In this way, supernova act like storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They are the destructive, luminous, and essential moments of chaos in the galaxy. Large areas of star formation are hidden by dust. The Milky Way is full of lights we cannot see. Clouds and tendrils of interstellar dust, which is composed of microscopic grains of ice, carbon, and silica, are found throughout the galaxy. It blots out stars and entire nebulae in visible light, obscuring large areas of space. However, star formation goes on behind this curtain. Through the dust, glittering nurseries full of newborn suns can be seen with infrared telescopes. What appears to be darkness is frequently a cradle. Despite its concealment, the dust contributes to the process by absorbing energy, aiding in the cooling of gas, and protecting sensitive phases of stellar birth. Often, what appears to be emptiness is actually the start of something bright. The galaxy is filled with gas clouds that are devoid of stars. Not all gas clouds turn into stars. Astronomers have discovered enormous, frigid clouds that appear to be about to collapse but are still dormant and dark throughout the Milky Way. Some are too dispersed, Internal turbulence or magnetic fields may stabilize others. Like silent possibilities, these starless clouds drift across the galaxy, abundant in molecular hydrogen but unaffected by fusion. One day, they might catch fire, or they might drift until outside forces tear them apart. They recycle their gas into other areas, perhaps waiting for the right prod to ignite something new. The galaxy holds its breath in these clouds. Matter is recycled throughout the generations in the Milky Way. Stars change over time. They burn, they die, they live. They also give their material back to the galaxy when they die. Heavy elements were dispersed by supernovas. The outer layers are shed by red giants. Nebulae that are planetary drift out into space after entering the interstellar medium. This enriched material cools, condenses, and eventually creates new planets, stars, and then life. All of your atoms have gone through this cycle, created in a star, dispersed throughout space, and reassembled into a new shape. The Milky Way is a powerful force for renewal, rather than a stagnant stage. It makes, unmakes, and starts again as it breathes in time with its stars. There are hints about the early universe in metal-poor stars. Metals are more than just iron and gold in astronomy. Any element heavier than helium is one of them, because they formed before previous generations of stars had an opportunity to forge and scatter these metals. The earliest stars in the universe contained nearly none of them. Today, astronomers search the Milky Way's halo for metal-poor stars. The chemical conditions of a bygone era are preserved by these faint and ancient stars. By examining their makeup, we can see into the early universe, into the time immediately following the Big Bang, before galaxies had fully developed and the galaxy itself had taken on its full form. They are light-based fossils. Some stars travel great distances from their birthplace. The destiny of a star is not always determined by where it was born. Due to orbital resonance, gravitational interactions, or the gradual pull of spiral arms, many stars eventually drift away from their natal clouds. Some stars are hurled into the halo or across the disk at high speeds. Others gradually migrate as they spiral through the galaxy, changing their orbits inward or outward. Not even our Sun is where it all started. The Milky Way is anything but static when one follows the trajectories of its stars. A galaxy teeming with activity, trade, and silent displacement. A star's home might be fleeting. Tens of thousands of light-years may separate the galaxy's habitable zone. The Milky Way may have its own galactic habitable zone, similar to how Earth circles the Sun in a Goldilocks zone that is neither too hot nor too cold for life. This area is believed to be situated between the outer edges of the metal core, where planet formation may be more difficult, and the hazardous inner core, which is full of radiation and gravitational chaos. A broad band with stable conditions, a moderate star density, and an abundance of elements like carbon, oxygen, and iron is located somewhere in the middle. This area includes Earth, one peaceful orbit in a huge whirlpool where life may not be the only thing trying to establish itself. There is no fixed structure to the spiral arms. The spiral arms of the Milky Way are not composed of fixed stars, despite their appearance as sweeping, permanent features etched into the galaxy's disk. Rather, they are patterns, density waves that cause gas to compress and new stars to form as they move through the disk. After drifting into these arms, stars shine for a while before drifting out once more. Like a traffic jam on a highway, the spiral structure travels at a different speed than the stars. It appears to be form and order from a distance. From the inside, it's a pattern of changing motion that is kept together by time and gravity. It's never still, always flowing. Cosmic radiation hums in the Milky Way. The galaxy glows with energy that is more enigmatic than visible light. Every second, cosmic rays-eye energy particles produced by distant galaxies and supernova stream through space and pass through your body. Black holes and dying stars emit gamma and X-rays. Pulsars, gas clouds, and the icy breath of hydrogen all emit radio waves. What light cannot see is revealed by these unseen hums. The ancient fires still flickering in the galaxy's bones, the violence, the magnetism. Only a small portion of the Milky Way's full spectrum is visible when gazing up at the night sky. A hidden symphony in the darkness. The galaxy hums softly beneath the stars, in a variety of colors and frequencies. The core is surrounded by a massive gamma-ray bubble. Two enormous ghostly lobes of high-energy light stretch tens of thousands of light-years above and below the galactic center. Only recently were the Fermi bubbles discovered. They radiate gamma rays that emanate from the heart of the Milky Way like twin balloons. Nobody knows for certain what caused them. They could be signs of intense star formation that once erupted through the core. Or they could be the remains of a long-ago outburst from the central black hole. In any case, these massive structures are unseen by humans and silently drift across the galaxy. They serve as a reminder that there is more to the Milky Way as history than meets the eye. Far above the familiar stars, there are echoes of violence wrapped in radiance. Between the major arms, we reside in a minor spur. The grand spiral arms of the Milky Way do not contain our solar system. Rather, we inhabit a tiny structure known as the Orion Spur, a comparatively peaceful starry lane tucked away between the arms of Perseus and the larger Sagittarius. Although it's not particularly active or dense, that might be the reason we're here. There are fewer massive supernovas in the quiet between galactic highways. Radiation storms are less common. It is possible that life on Earth had the time it needed to arise and develop in this peaceful nook. The galaxy appears bright and dramatic from the periphery. However, we discovered just enough tranquility in this peaceful spur to allow complexity to develop. The center of the Milky Way is shaped like a bar. Astronomers see a thick, elongated bar of stars that crosses the center of the galactic core in infrared light, resembling a glowing bridge rather than a perfect circle. The inner spiral arms are shaped by the gravitational pull of this slowly rotating bar. Spiral galaxies frequently have bars like this one. They are created when stars in the disk start to accumulate along a central axis and drift inward. The bar eventually stabilizes, agitating gas, igniting new stars, and supplying material to the central black hole. It is a dynamic engine that shapes the galaxy's core from within. Not just a shape, it is a component of the local group, a more expansive structure. The Milky Way is not an isolated entity. It is a member of the local group, a tiny cluster of more than 50 galaxies that are all drifting through space together. With their own families of satellite galaxies, the Milky Way and Andromeda are the two largest members. Smaller dwarfs, faint ellipticals, and star-poor galaxies composed almost entirely of dark matter are scattered around them. The local group, which spans more than 10 million light-years, is connected by gravity rather than just proximity. Even though we live far apart, we are all connected by the unseen threads of our shared motion and attraction to one another. Local group galaxies are gravitationally bound. The galaxies of the local group are not drifting apart, even though they are very far apart. Actually, a lot of them are slowly approaching each other. Their paths are curved over millions of years, as gravity keeps them in a sort of slow-motion ballet. Like moons, some of the tiniest galaxies circle the Milky Way, looping and descending until they dissolve into streams. Others drift on their own, but they are bound together by a web of collective motion. This group may condense over time. Galaxies can be absorbed, fade, or merge. Time, inertia, and gravity's long reach have brought this family of cosmic islands closer together rather than making it a static arrangement. There are two components to the galaxy's disk, thick and thin. From a distance, the Milky Way's disk appears flat, but up close, it is layered. We live on the thin disk. Young stars, open clusters, and star-forming gas are all present in this broad, dense plane. However, the thicker, older, puffier, and more diffuse disk is located above and below it. Older stars with fewer heavy elements are more common in the thick disk. Their more elliptical and tilted orbits indicate that they were agitated by early galactic collisions or formed under different circumstances. The disk of the galaxy is irregular. Like sediment deposited on the bottom of a cosmic ocean, it has been layered, sculpted, and textured over time. The disk is threaded by the galaxy's magnetic field. A massive magnetic field that stretches across the disk, rises into the halo, and weaves through the interstellar medium is present throughout the Milky Way. Despite being invisible to the naked eye, although this field is weak by earthly standards, it influences the motion of cosmic rays the collapse of gas clouds, and the movement of matter across space over galactic distances. It twists into loops that defy easy explanation, aligns with spiral arms, and forms arcs above the plane. Radio telescopes and meticulous analysis are needed to study it. But there is no denying its existence. There is more to the Milky Way than just light. With a faint pulse coursing through its bones, it breathes with magnetism. There are many unseen structures in the interstellar medium. There is more than emptiness between the stars. A thin mixture of gas, dust, and plasma, known as the interstellar medium, moves through the Milky Way like a fog. It is largely invisible to the unaided eye. However, it exhibits a remarkable intricacy when observed through radio and infrared telescopes. It creates shock waves, filaments, bubbles, and cold, dense clouds that give birth to stars. Large holes are created in it by supernovas. Shapes formed by stellar winds ripple across light. Instead of being a vacuum, the area between stars is a dynamic network of matter and magnetism, the silent fabric that eventually gives rise to life and galaxies. We are continuously exposed to cosmic rays from the galaxy, high-energy particles, primarily protons, and atomic nuclei, that were created by long-gone star explosions flow through your body every second. Cosmic rays are ubiquitous. They move at nearly the speed of light, bending through magnetic fields, reflecting off clouds, and sometimes colliding with atoms in the Earth's atmosphere to produce secondary particle showers. We rarely notice them, but they are carrying messages from the violent harps of stars, evidence of ancient supernovas, stories from across the galaxy, and traces of distant acceleration. The galaxy is whispering in particles, in silence, in lightless rays, even while you are sleeping. Despite being depicted in many diagrams as a tidy, even spiral, the galaxy is not symmetrical. There are imbalances in the Milky Way. The disk seems thicker on one side. Spiral arms vary in length, curvature, and brightness. The outer disk has an uneven warp. There is even a slight discrepancy in the number of stars between the hemispheres. Gravitational encounters, previous mergers, or the impact of dark matter could all contribute to these asymmetries. They remind us that galaxies have character and depth because, like living things, they bear the scars of collisions, the wrinkles of time, and the peculiarities of uneven growth that are remnants of their past. Our halo might contain the oldest known star. Astronomers found a star that might be almost as old as the universe itself, floating through the halo high above the galactic plane. Its near absence of heavy elements is indicative of stars that were formed shortly after the Big Bang, before the universe was enriched by generations of supernova, long before the Milky Way was completely formed. Probably more than 13 billion years ago, it formed, low in mass, but rich in history. It now burns softly red and quietly. It's more than a star. It is a living relic from the early dawn of the universe, a time capsule. In the Milky Way's inner regions, the galaxy's center rotates more quickly than its periphery. Stars that are closer to the center orbit considerably more quickly than those that are farther away, with mass from stars, dust, and the supermassive black hole, Sagittarius A*. The gravitational pull is stronger close to the core. Stars complete revolutions in a matter of millions of years as a result of sweeping through tighter, faster orbits. Stars orbit more slowly in the galaxy's suburbs, such as where our sun is located, taking hundreds of millions of years. This irregular rotation prevents the disk from acting like a solid structure, stretches spiral arms, and produces twisting patterns. Like a great wheel, the galaxy moves. However, the rim is not as fast as the core. Density waves form the spiral arms. The Milky Way's spiral arms are not stationary star trails. Waves of greater density traveling through the galactic disk create these patterns. Compressed gas and dust travel through these waves, causing star formation and illuminating the arms with young, bright stars. As new stars emerge behind them, these stars eventually drift out of the wave, giving the appearance of a self-sustaining structure. The arms are dynamic and constantly moving, much like pond ripples or traffic on a highway. At a distance, they seem motionless. They are a dance of rhythm and matter from within, molded by time and gravity. Cold, collapsing gas gives rise to stars. Star formation, starts silently in the Milky Way's dark arms, chilled to a few degrees above absolute zero. Massive clouds of molecular hydrogen, sometimes hundreds of light-years wide, drift through space. Gravity gradually establishes itself within these clouds. Little areas get denser and start to give way under their own weight. The gas flattens, spins, and heats as it descends inward, creating a protor in the middle. A new star is created when nuclear fusion ignites as a result of increasing temperature and pressure over time. The quiet force of gravity gently spins the brightest lights out of the coldest shadows. It is possible for star clusters to vanish into the galactic field. Many stars are born in groups rather than alone. The same cloud of collapsing gas formed tight clusters. For millions or even billions of years, these mutually gravitationally bonded clusters drift together. However, they eventually start to disperse. Clusters are pulled apart by internal dynamics, close encounters with other stars, and tidal forces from the Milky Way's mass. One by one, stars separate, causing the cluster to disappear into the galaxy's overall star. Long ago, even our Sun was born in a stellar cluster. Now, its siblings were dispersed, dimmed, or lost in the distance. There are old hypermetal-poor stars in the galaxy. Hypermetal-poor stars are among the rarest and most valuable objects in the Milky Way. Stars with nearly no elements heavier than helium in their atmospheres. Less than 110,000th of the iron in the Sun is present in some of these. These stars, which have only slight signs of enrichment from a universe that is still forming, are thought to be among the first to be born following the first supernova. Like far-off lanterns from the beginning of time, they are strewn throughout the halo and are extraordinarily old and pure. A glowing, gravitationally bound signature from a nearly forgotten era. Each one is a sort of relic. The Milky Way is home to planetary systems. Planets are a common occurrence in the universe. They naturally result from the formation of stars. A revolving disk of residual gas and dust envelops a newly formed star. As it ignites, particles cling to one another, accumulate mass, and develop into worlds inside this disk. Planetary systems are widespread throughout the Milky Way. Some are enormous, with frozen moons and gas giants. Some are small, with rocky planets clinging to faint stars. Some might be similar to our own, while others completely defy our expectations. There is more to the galaxy than just stars. It is full of solar families and systems, each with its own potential, orbit, and balance. The rotation radius is close to Earth. The spiral arms in the Milky Way rotate more slowly than individual stars, resembling a flowing pattern rather than a stable structure. However, there is a specific distance from the center known as the corotation radius, where the average star speed is equal to the spiral arm's own rotational speed. The Sun of Earth circles near this line. We might be able to avoid frequent spiral arm crossings, areas with higher star densities, morae supernovae, and gravitational disruptions. Thanks to this gentle match in motion, we may reside in a more stable area of the galaxy, protected by resonance rather than walls. Through the galactic plane, the Sun bobs up and down. The Sun does not travel in a perfectly flat orbit around the Milky Way. Rather, it rises and falls over tens of millions of years in a soft wave, drifting above and below the galactic plane like a cork in slow motion. The gravitational pull of the galaxy's mass is what causes this vertical oscillation. As the solar system moves, it is pulled and released, although the evidence is still unclear. Some scientists have even questioned whether this motion could affect Earth's extinction cycles. It serves as a reminder. Though the Sun is not gliding, even as it circles the center steadily, it is gently swaying across space. Although the nature of dark matter is unknown, its existence is known. The majority of the Milky Way's mass is made up of dark matter, which has never been directly observed. Light is neither emitted nor absorbed by it. It passes through ordinary matter as if it weren't there. However, there is no denying its gravitational effects. It holds the galaxy together, explains the unexpected rotation speeds of stars, and shapes the formation of large-scale cosmic structures. The Milky Way would disintegrate without it. Instead of seeing it, astronomers can detect it by observing how it moves other objects. One of the biggest mysteries in science. It is the invisible, silent scaffolding that supports the galaxy. The disk's exterior has more mass than its interior. The flat, luminous disk contains the majority of the Milky Way's visible stars, but the bulk of its mass is located elsewhere. Beyond the farthest stars, the galaxy is encircled by a massive dark matter halo. The galaxy is held together by this halo, which greatly outweighs the disk. It is populated sparsely with ancient stars and globular clusters, but its true bulk is unseen. Our first impression of the Milky Way is of its starry plane and spiral arms, but that's just the surface that glows. Like a silent shroud, the mass that defines the galaxy, its gravity, its motion, and its reach is largely concealed. It's possible that the core of the Milky Way flared as a quasar. There is evidence that our galaxy as heart was once much more active than it appears to be today. The supermassive black hole at the center may have once flared as a quasar, a brilliant, violent beacon powered by infilling matter. According to the existence of massive gamma-ray structures like the Fermi bubbles and traces of high-energy light reflected in nearby clouds, quasars outshine entire galaxies, making them some of the universe's brightest objects. The Milky Way would have appeared drastically different, a spiral encircling a blinding heart of light, if it had once burned like this. The echoes are still there, even though that time has passed. Over billions of years, the structure of the galaxy changes. Galaxies are constantly changing, despite their seemingly timeless appearance. Arms in a spiral move, bars are formed and then dissolved. Gas moves both in and out. The population of stars changes as they are born and die. Even the shape of the Milky Way's disk, warped, rippling, and lopsided, is slowly altering. The structure may be bent or twisted by interactions with dark matter and dwarf galaxies. Like a drifting cloud, the galaxy's silhouette has changed over billions of years. The Milky Way of today is neither what it was, nor what it will be. Its quiet transformation, rather than its permanence, is what makes it so beautiful. Distant mergers cause gravitational waves to reverberate throughout the galaxy. Massive objects collide. Black holes spiral together, neutron stars crash, and entire galaxies merge throughout the universe. These events send out gravitational waves, ripples in the fabric of spacetime itself. Some of these waves, albeit weak, travel through the Milky Way, slightly warping space along the way. Although they are extremely hard to find, several have already been captured by observatories like Virgo and LIGO. Finding the background hum of gravitational waves that permeates the universe is the goal of new experiments. Space itself is changing even while you're sleeping. Not enough to sense, but enough to let us know that the universe is changing in the distance. Some stars follow long slanted orbits. Not all stars move in neat circles around the galactic center. Some trace long, stretched ellipses that are tilted at odd angles from the main plane and loop high above and far below the disk. These stars, most likely, have distinct origins, survivors of past gravitational upheavals or remnants of dwarf galaxies absorbed by the Milky Way. Their orbits serve as hints and three-dimensional charts of the galaxy's turbulent history. Astronomers reconstruct the invisible architecture of the Milky Way's mass and memory by tracking their motion. These stars, twisted and stretched, but still connected to the whole, float like messengers from broken systems. The Milky Way emits neutrinos we can barely detect every second. From the stars, trillions of neutrinos travel through your body. The sun, supernovas, and cosmic rays striking atoms in space all produce these spectral particles through nuclear reactions. They are all over the Milky Way. However, they pass through practically everything undetected because they are so light and unreactive. Only a few are captured by special observatories buried deep underground or under ice. Light bursts from an uncommon collision. Information from unseen sources, such as collapsing giants, stellar cores, and the galaxy's unseen energy, is carried by neutrinos. They are cosmic fire's whispers. There are things in interstellar space. It is a rough sea. Space is neither still nor smooth between the stars. Star motion, magnetic fields, and shock waves all cause the thin clouds of gas and dust that make up the interstellar medium to move. The temperature can fluctuate greatly. Material flows clash, blend, and break apart. Clouds fold, tumble, and stretch. Large-scale turbulence is produced by this, resembling a slow-motion ocean circling the disk. This restless sea influences cosmic rays, star formation, and even galactic evolution. What appears to be serene starlight from a distance is actually a dynamic, rippling fabric that has been shaped by ancient energy and invisible winds. There might be rogue planets in the galactic halo. Not all planets are bound to stars. Some are subsequently expelled from their systems after forming normally. Some might never have had a scar at all. These are cold, dark, and solitary rogue planets and worlds that drift through the galaxy. Studies indicate that there might be billions of them in the Milky Way, some even in the outer halo, where stars are scarce, despite the fact that they are hard to find. They float unseen in the absence of warmth and light. They are orphans of the galaxy, planetary drifters traveling long, lonely routes through the darkness between stars, warmed only by internal heat. The cosmic dust flow is shaped by magnetic fields. Tiny carbon and silicon particles known as interstellar dust move due to the galaxy's magnetic field in addition to gravity. Like unseen currents, these fields flow through the Milky Way, directing the motion of charged particles and affecting the alignment of gas and dust. Dust grains spin quickly in some areas, producing weak microwave light. In others, they polarize the starlight that travels through them by aligning with magnetic lines. Astronomers can trace the structure of the magnetic field and even eliminate its influence from cosmic background studies by comprehending these effects. Dust is not a passive substance. It falls into concealed patterns in the dark while dancing to a magnetic beat. Collisions between neutron stars enrich some stars. A kilonova, one of the universe's most violent events, is created when two neutron stars spiral together and collide. Huge amounts of heavy elements are forged in this brief, blinding explosion. Uranium, platinum, gold, and more. After being launched into space, these materials combine with gas to form new stars, enriched in elements that could only have resulted from such collisions. Certain stars in the Milky Way bear the chemical fingerprints of these infrequent occurrences. In addition to being bright borders, they are also archives of past apocalypses that are blazing with the remains of star wrecks and cosmic alchemy. There might be a secret bar inside a bar in the Milky Way. A bar of stars. A long bridge of light that crosses the central bulge is located at the center of the galaxy. However, astronomers have discovered evidence of a smaller bar that rotates independently and is tilted at a different angle deep within that bar. The motion of nearby stars and gas reveals the gravitational influence of this inner structure, which is hard to see, directly due to dust and distance. These kinds of bars could aid in feeding the supermassive black hole and influencing its dynamics by directing material toward it. The core of the Milky Way is not a single, straightforward shape. It's a shifting, multi-layered maze of motion and light. The cosmic web provides the galaxy with gas inflow. There is no closed system in the Milky Way. Fresh gas from the intergalactic medium is drawn in by it. The vast cosmic web is filled with long, thin streams. By replenishing what the galaxy gradually loses, these inflows supply the building blocks for new stars. Some of the gas enters the disk as silent, cold filaments. Other streams light up in ultraviolet or X-ray light as they fall in hotter, shock-heated forms. These unseen rivers support the galaxy's expansion and development, and connect it to the wider cosmos. The Milky Way is still fed by threads of matter, spun from the early universe, drawing from far-off reservoirs. Bubbles of hot gas emerged from the disk as chimneys. Massive cavities are formed in the interstellar medium when clusters of massive stars explode as supernovas. Superb bubbles, which are enormous pockets of hot gas that punct upward through the galactic disk and vent into the halo, can form from these. The end effect is a channel that allows gas, magnetic fields, and energy to escape from the galaxy's plane, resembling a chimney. These chimneys redistribute metals, control the interstellar medium's pressure, and aid in halo structure formation. In this manner, the galaxy breathes not only inside the disk, but also through tall columns that radiate its energy into the night. Old stars and black holes emit X-rays that illuminate the galaxy. The Milky Way glows fiercely in other wavelengths, but appears calm in visible light. Its core, collapsed stars, and the edges of black holes all emit in binary systems. White dwarfs and neutron stars have the ability to siphon matter from their companions and heat it to millions of degrees. Faint X-rays are also released by hot gas in the halo, exposing the larger skeleton of the galaxy. This high-energy light is invisible to the human eye. However, a completely different picture of the galaxy is presented by telescopes like Chandra and XMM Newton. It was a world of intense heat, compact remnants, and concealed radiation, not a peaceful spiral. All across the Milky Way, pulsars serve as cosmic clocks. A massive star may be left spinning quickly and precisely, with radiation beams sweeping across space when it dies and collapses into a neutron star. Some of these are pulsars, which rotate hundreds of times per second and pulse in predictable, regular patterns. Astronomers use them as cosmic timekeepers, tracking their signals to measure distances, test gravity, and even look for gravitational waves because they are so reliable. Pulsars are silent, blinking stars in the Milky Way, remnants of death, but also shining examples of incredible order. They tick steadily in the quiet between stars, keeping time not for minutes or days, but for entire epochs. The galaxy's hidden structure is mapped by radio waves. A large portion of the Milky Way is obscured by dust, distance, or faintness, making it invisible to the naked eye. However, radio waves are able to pass through these obstacles and reveal otherwise invisible structures. They highlight emissions from pulsars, supernova remnants, and even far-off quasars outside the galaxy, trace cold hydrogen gas, and outline magnetic fields. Astronomers have measured the disk's warp, mapped the spiral arms, and found star-forming regions hidden in darkness using arrays of radio telescopes. Radio soundings allow us to see where light is blocked. Science has learned to translate the galaxy's unintelligible language into shapes and shadows. Most likely, a stellar cluster is where the sun was born. Seldom do stars form alone. Typically, they are formed from the same collapsing cloud of gas and dust, forming stellar clusters. Most likely, our sun was one of these. It was once in the same cradle as hundreds or even thousands of sibling stars. The cluster was gradually dispersed by the motion of the galaxies, gravitational tides, and passing stars. The majority of the sun's siblings have strayed far and been hurled into various orbits, bringing with them fears of our common history. Some might still be shining close by, lost family in a sea of light, invisible among the stars. The siblings of the sun are dispersed throughout the galaxy. Astronomers are looking for the sun's lost siblings, stars that have the same age, motion, and chemical fingerprint as the sun. Even though its birth cluster has long since disintegrated, researchers hope to find these long-lost relatives using spectroscopic databases and large surveys like Gaia. A few contenders have surfaced. The same cloud of enriched gas may have given rise to stars that were similar to our own. If discovered, they might provide information about the circumstances surrounding the formation of the sun and the early solar system. We are not completely alone in our position in the galaxy. The sun's ancient relatives might still be shining somewhere. The spinning galactic disk wobbles. The disk of the Milky Way is not entirely flat, like a spinning plate that has been knocked off balance. It wobbles softly and ripples. The outer areas, where the disk bends upward on one side and downward on the other, are where this warp is most noticeable. It could be brought on by interactions with dark matter, internal asymmetries, or the gravitational pull of nearby dwarf galaxies. Like a huge wave passing through the stars, the wobble rotates slowly. We don't sense it from Earth. However, the Milky Way is not a perfect spiral when viewed from a distance. It is a gently curved sheet of stars that is breathing and undulating. Star streams and clusters can be distorted by galactic tide. The vast mass of the Milky Way exerts tidal forces on everything within it, much like the moon's gravity pulls tides on Earth. The galaxy's unequal gravitational pull is felt by star clusters, satellite galaxies, and even globular groups. Long stellar streams may be drawn out, or stars may be peeled from their orbits as a result of these tides' gradual stretching and distortion. These encounters left behind many of the faint star arcs that are mapped across the sky. The process involves the unraveling of clusters. Galaxies are slowly being ripped apart. These structures are not abruptly broken by the galaxy. Over millions of years, it carefully unravels them. strand by strand. The mass of the Milky Way is still unknown. The mass of our own galaxy is remarkably difficult to measure, despite the fact that you might think we would know it. Only a small fraction is made up of gas and stars. The remainder is hidden in the enormous dark matter halo, which is invisible to us. Estimates differ. A mass that is nearly 1 trillion times that of the Sun is proposed by some. Some people think it's much higher. Due to a lack of data and the impact of invisible matter, it is difficult to determine how quickly stars orbit at large distances. Our home is the Milky Way, but its weight is still a mystery. Perhaps it weighs more than Andromeda. Astronomers believed for a long time that the Andromeda Galaxy, which is marginally bigger and brighter than the Milky Way, is also more massive. However, new measurements indicate that the dark matter halo around the Milky Way might be denser and wider than previously thought. Even though Andromeda appears more modest, our galaxy might surpass it, if that is the case. This is important for predictions, as well as comparisons. The dynamics of the encounter will be influenced by the relative masses of the two galaxies when they eventually merge. Despite its serene spiral arms, the Milky Way is heavier than we once thought. It's possible that the melanic clouds are in their first orbit. It has long been believed that the Milky Way is orbited by the large and small melanic clouds, two bright satellite galaxies that are visible from the southern hemisphere. However, fresh data indicates that they might be recent cosmic arrivals. Their motion and speed in space suggest that this might be their first close encounter. If accurate, they are far-off nomads who are just now succumbing to the Milky Way's allure rather than lifelong friends. Their arrival has distorted the galaxy's shape and agitated the outer disk. The quiet of the sky is filled with first encounters, as though the Milky Way is reacting to a new gravitational visitor. A ribbon of stripped gas is the melanic stream. Behind the melanic clouds is a huge ribbon of gaseous hydrogen, a structure known as the melanic stream, stretching across the southern sky in arcs and curves. It spans hundreds of thousands of light years. As the dwarf galaxies passed near each other and the Milky Way, tidal forces dragged this stream away. It is an invisible light that manifests as a long trailing whisper of motion and loss in radio wavelengths. One day, the stream might settle into the halo like a thread of memory connecting galaxies, or it might feed new star formation in the Milky Way. Polar orbits are exhibited by certain gas clouds. The disk's neat plane is not followed by everything in the Milky Way. In highly inclined orbits, some gas clouds, and even some stars pass above and below the main structure of the galaxy. These polar orbits most likely resulted from mergers in the past that captured stray clouds or dwarf galaxies at strange angles. Over time, they had persisted in their slanted orbits, resembling comets circling a planet. These orbits that are out of alignment are evidence of disturbance. Visible indicators that the galaxy is an evolving structure formed by the erratic flow of cosmic history rather than a closed system. Past starbursts are surrounded by enormous gas shells. Astronomers have discovered massive spherical shells of gas in a number of Milky Way regions, some of which extend hundreds of light years. The remnants of strong starbursts, which occurred when groups of massive stars formed together, lived short lives and exploded quickly, one after the other. Are these shells? Gas was blown out in all directions by their combined winds and supernova, which created enormous holes in the interstellar medium. The expansion slows down over time, but the shells are still there. Where the galaxy once blazed brightly with stellar birth and death, there are ghostly bubbles. The remnants of cosmic fireworks that continued to reverberate in the cold are these. In dense areas, stars sometimes collide. Stars are tiny, and space is vast. However, stars can get close enough to interact or even collide in the Milky Way's densest areas, like the centers of globular clusters. The outcome can be dramatic when they do. The creation of a rare blue straggler star, which appears younger than its neighbors, the merging of two suns, or a burst of light. Although uncommon, these collisions are still possible. Gravity and chance can cause the teetest stellar neighborhoods to reorganize over billions of years. Time flows differently in these densely populated stellar cities, and space is never completely empty. Tidal forces have the power to tear apart binary stars. Numerous stars orbit one another in a gravitational embrace while living in pairs. However, this bond is also breakable. Tidal forces can cause a binary system S-orbit to be disrupted when it passes through a dense cluster or near the Milky Way's central black hole. This can cause one star to be thrown away, while the other is slowed or captured. Sometimes, a companion is thrown completely out of the galaxy, turning into a rogue star that speeds through intergalactic space. In locations we hardly ever see, these stellar breakups occur quietly, a silent tearing of long-standing alliances by gravity's other hand. Some stars completely leave the galaxy. A star may occasionally reach an escape velocity of more than 500 kilometers per second and be launched outward, never to return. But the majority of stars are gravitationally bound to the Milky Way. Although they are uncommon, these hypervelocity stars exist. Some are believed to be expelled as a result of interactions with the galaxy's central supermassive black hole. Supernova, in binary systems or three-body encounters, may slingshot others. They enter intergalactic space by themselves after being set free. Drifting well beyond the edge of the spiral are tiny lighthouses. They become lone travelers in the vast void between galaxies, carrying the galaxy's memory outward. Stars from other galaxies can be found in the Milky Way. Not all of the Milky Way's stars were born here. Some might have come from other galaxies, been caught in mergers, or been thrown into our halo from far-off parts of the local group. These intergalactic travelers frequently follow paths through the halo or outskirts of the disk on peculiar orbits. Stars that don't quite fit the local patterns can be recognized by their motion or composition. They bring tailies from different settings, eras, and skies. Much like cosmic immigrants, the Milky Way is not a closed system. It is a living mosaic that has been gradually pieced together by motion and time. The galactic fountain is a silent loop of gas rising and falling between the disk and halo, above and below the bright disk of the Milky Way. Material is heated and ejected upward into the halo by stellar winds and supernova, where it cools, condenses, and then gently rains back down over millions of years. This cycle helps control star formation, redistributes heavy elements, and stirs the interstellar medium. Between the vast halo and the dense plane, there is a silent, breathing motion of matter. In Teeth Sensei, the galaxy does more than simply spin. It moves around. It breathes in and out, maintaining the motion of its structure over very long periods of time. Organic compounds are carried by the dust grains in the galaxy. Scientists have found complex organic molecules, which are carbon-based compounds that are the building blocks of life. Within the clouds of interstellar dust that drift between stars, these consist of simple sugars, alcohols, polycyclic, aromatic hydrocarbons, and more. Despite not being living, they are chemically rich and were created in cold, radiation-shaped clouds or the atmospheres of dying stars. Galactic winds carry these microscopic grains across light years, where they settle into the gas that gives rise to planets and stars. The early Earth might have been hit by some of them. The dust of the galaxy is more than just rubble. It is a load of possibilities floating through the night in silence. Solar systems may receive life-giving elements from interstellar clouds. Worlds are born in the same places as stars. Planetary systems acquire the chemical signatures of their parent nebula as they develop from collapsing gas and dust clouds. Water, carbon compounds, and other biological building blocks may wind up in comets, asteroids, or planets if they are present in that cloud. Such prebiotic chemistry is particularly abundant in some areas of the Milky Way. Although the prevalence of life is unknown, the prerequisites for it appear to develop spontaneously. It's possible that the seeds of life are dispersed widely, nestled in the coldest cradles of the galaxy, just waiting for a place to sprout. Compared to the Sun, some stars rotate hundreds of times faster. While the majority of stars rotate, some spin so quickly that they can complete a full rotation in a matter of hours. With bulging equators due to centrifugal force, these fast rotators are frequently young, large, and unstable. Some accelerate to such high speeds that they launch debris, encircling themselves with glowing disks. Depending on latitude, the Sun rotates once every 25 to 35 days. However, these fast-spinning stars are getting close to their physical limits as they rotate hundreds of times faster. Their evolutionary histories and internal structures differ. Even though their lives are short, They whirl like sirens in the night. In relation to the ecliptic, the galaxy is tilted. Although the Milky Way is a beautiful band of light that arcs across the night sky from Earth, it is not in line with the plane of our solar system. The ecliptic, the path taken by the Sun and planets, is about 60 from the galactic plane, the flat disk that contains the majority of the galaxy's stars. The Milky Way rises at an angle and changes position with the seasons because of this tilt. Although our small system is slightly skewed, we are a part of the galaxy, a tiny, slanted boat floating in a vast, whirling sea of stars. The disk of the galaxy is not as old as some stellar remnants. Astronomers have discovered white dwarfs, the cooling cores of bright stars that are older than the thin disk of the Milky Way itself, among the faint stars in the halo. Before the galaxy's main structure had completely settled, these ancient remnants formed. Their presence suggests a more ancient star formation period, a more profound past engraved in the outer halo. The silent remnant of a time when the Milky Way was still taking shape is carried by them as they gradually fade after burning for billions of years. The halo remembers farther back, even though the disk is bright. The stars that are the furthest away from the main structured orbit far away. The most distant stars in the Milky Way orbit tens, or even hundreds of thousands of light years from the center, well beyond the well-known spiral arms. These stars take billions of years to complete a single orbit, traveling slowly and widely through the galactic halo. Many were probably taken from smaller galaxies during previous mergers, and are now floating like far-off sentinels in the outermost reaches. They contribute to defining the size, shape, and gravitational influence of the galaxy. But they are weak, few, and far between. There is more to the Milky Way than meets the eye. Shaped by wanderers at its edge, it stretches far into the darkness. The Milky Way is asymmetrical in a number of ways. The Milky Way is slightly lopsided. Despite being frequently depicted as a symmetric spiral, the disk has a thicker side than the other. The brightness and extent of the spiral arms, the stellar halo, is also a little offset. These asymmetries most likely result from past mergers, dark matter clumps, or gravitational interactions with the melanic clouds. The universe is not a flawless pinwheel, like a whirling dancer whose skirt has been caught in the wind. It is a living structure characterized by tugs and twists. That irregularity, a tasteful imbalance carved by time, is what makes it so beautiful. Variable stars are used by astronomers to map the galaxy. Like slow, bright heartbeats, some stars pulse in brightness at regular intervals, expanding and contracting. These are variable stars, and there are known correlations between the brightness and pulse period of some types, such as Cepheids, and astronomers can calculate a star's distance and true luminosity by measuring how long it takes for it to brighten and dim and comparing the two. By acting as cosmic yardsticks, these stars assist us in charting the Milky Way's size, composition, and form. The dark blinking beacons strewn throughout the spiral are lights that measure. Our knowledge of the Milky Way is being revolutionized by the Gaia mission. The Gaia spacecraft, launched by the European Space Agency, is producing the most accurate map of the Milky Way to date. Gaia provides information about the galaxy's three-dimensional structure and motion over time by analyzing the positions, motions, and brightness of more than 2 billion stars. It has mapped the disk's warp, discovered streams from torn galaxies, and meticulously charted the Sun's orbit. Gaia expands our knowledge with every new data release, transforming a fuzzy smear of stars into a precise, dynamic map. It is the most ambitious star chart in astronomy, a silent revolution taking place among the stars. A dense star path is indicated by the galactic plane. On a night without city lights, you might notice a blurry river of starlight flowing across the sky. The thickest portion of the Milky Way's disk is known as the galactic plane. The bulk of the galaxy's stars are located in this enormous, flattened band, which is not a line. Star formation is frequent. Dust is layered, and stars are closely spaced throughout this plane. From our position, we are looking through the galaxy's most opulent passageways, along its grain. This band is more than just gorgeous. The majority of stars reside and pass away in this congested, bustling center. The galactic center is where the night sky is brightest. The constellation Sagittarius, a rich, glowing concentration of stars, dust, and invisible mass, is located in the direction of the Milky Way's core. We are unable to see the very center in visible light from Earth. Our view is obscured by dust clouds, but the region is bright in radio and infrared. The area appears more densely populated, brighter, and filled with the overlapping light of billions of stars, even to the unaided eye. We orbit in a peaceful galactic disk suburb, far from this center. However, when we turn inward, we see the crowded city at the center of the galaxy. From Earth, we can see the Milky Way, John. We can't look down on the Milky Way from above, because we live inside it. Rather, it appears to us from within as a flat ribbon of stars that is only curved by the horizon. The galaxy is compressed into a single arc in this John view, making it difficult for us to understand its entire structure. The spiral to which we belong was discovered after centuries of observation, cataloging, and mathematical inference. From Earth, we look through its disk, as if we were standing in a forest and following the tree line. We only see the vastness that envelops us. We do not see the shape of which we are a part. There is much more in the galaxy than we could ever see. We can only see a small portion of the Milky Way, even with our most sensitive instruments. Light is blocked by dust. Silence conceals motion. Luminous stars are outnumbered by dark matter. There is potential in every empty space and emptiness between every star. There is more to the Milky Way than meets the eye. It is what we want to know, what we suspect, and what we deduce. It contains drifting worlds, future stars, ancient light, and unanswered questions. And in that vastness, we somehow find ourselves floating through a story too big for the eye, one planet among many, orbiting a silent star. And now, behind your thoughts, the stars start to fade. We have wandered through 100 silent realities, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. You've wandered through stellar nurseries, danced along spiral arms, and gazed toward the galactic heart, glowing behind curtains of dust. This galaxy includes you, not merely a traveler on Earth, but an active participant in its protracted and bright development. Stars were used to forge the iron in your blood. Ancient explosions sculpted the oxygen you breathe. The atoms of your body trace their lineage to the earliest times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. The galaxy turns on tonight while you sleep. Stars are starting to form. Light is moving. Orbits remain silent. You're floating inside it, too. Nestled in the spiral arm of a calm, glowing sea, a tiny glimmer of warmth in the darkness. Now is the time to watch the next chapter. If you are still awake, I wish you a restful night's sleep and peaceful dreams. Good night.